Good morning, students. In the previous class, we have done two activities to know about the types of mixtures. In the first activity, we have classified mixtures as homogeneous and heterogeneous. You can see for a heterogeneous mixture, the particles are not uniformly spread out. But for a homogeneous mixture, the two different kinds of particles shown in two colors are uniformly distributed. Now, we are going to differentiate homogeneous and heterogeneous mixtures. Homogeneous mixtures have uniform composition. The particles are spread uniformly throughout. Can you give an example? Yes, sugar solution is homogeneous in nature. Even water in alcohol is a homogeneous mixture. On the other hand, heterogeneous mixtures have non-uniform composition. The example of wheat flour in water is a heterogeneous mixture. If you consider a mixture of oil and water, it is also heterogeneous in nature. In the second activity, we have learned that mixtures are classified as solution, suspension, and colloid. Mixtures of copper sulfate and water, potassium permanganate and water in the beakers A and B are solutions. They pass through the filter paper completely as their particle size is very small. The mixture of wheat flour and water in the beaker C is suspension. When passed through the filter paper, the particles of wheat flour do not pass and they remain on the filter paper as residue because the particles of the wheat flour are bigger in size. The example of colloid is milk, which we have taken in beaker D. Even though it passes through the filter paper, the particle size is larger than that of a solution. Now, if you look at the slide, you can see the light being focused from a torch on a glass containing a solution. In this case, the path of light is not visible, but when light is focused on a suspension or a colloid, the path of light becomes visible. This effect is called Tyndall effect. It is due to the scattering of light by the particles of the mixture. Solution does not exhibit Tyndall effect because the size of the particles are very small and are not enough to scatter the light. Suspension and colloid show the Tyndall effect. Now we are going to differentiate between solution, suspension and colloid, taking into consideration a few parameters. The first one, size of particles. For a solution, they are very small and we cannot see them by our naked eyes. Suspension, the particles can be seen by naked eye. For colloid, even though we cannot see them by our naked eye, they are larger. That is, the particles size is larger than the particles of a solution. Coming to the second point, it is Tyndall effect that we have discussed just now. Solution does not exhibit Tyndall effect, but suspension and colloid do exhibit Tyndall effect. The third one is whether they are stable or unstable. What do we mean by this? Supposing, for example, if you take the mixture of wheat flour and water in a glass and leave it without disturbing, after some time you can see the flour particles settle down at the bottom. So we say suspension is unstable. On the other hand, solution and colloid are stable. In our next class, we are going to discuss more about solution and its properties. For today, we will stop our class here. I hope all of you are able to follow the lessons. Thank you.